Hello and welcome again to my Physics Online video series. Today's video we're going to be doing the DC Circuits Lab walkthrough. This version is basically just resistors in combination, so we're looking at resistors in series and parallel and so on. And so we'll be doing the walkthrough of the basic instructions and calculations. As always, if you're watching this video, you're taking the course, therefore you should have access to the lab handout, and you should read this lab handout before you come to this video. The point of the video is not for you to get all the instructions you need for doing the lab. You should really read this lab before you watch the video. There are, in some sense, this one's a little longer than last time's. So last one was the Ohm's Law lab. That one was very short. This one, you have kind of five steps that you're going through, or procedures that you're going through. Each procedure individually is fairly short, but there are 5 of them, so you've kind of been warned. Go ahead and click through to the lab, and then the instructions basically say begin with a couple of resistors, each at 60 ohms, and place them in series. So what does that mean? That means that I need to have a resistor, I need to have a second resistor. They need to be in series in order to set the value of these to 60 ohms. You click on the resistor, come down to this little slider, and drag it to 60 ohms. If you miss or just get close, and then use the little arrows to click it into place. So do the same with this one. There's 61, so I use the little arrows, bring it down to 60. Now I need to basically wire these all in series with each other. I'm going to put this here, going to put a wire here. Ultimately, what we're going to be doing is measuring current entering the first and leaving the second, and in between the two. We're going to repeat this with them in parallel. We're also going to want to know what the voltage drop is across each resistor. So collectively, what that means that you're doing is you've got a voltmeter, you've got an ammeter. Now the ammeter actually allows you to do multiple locations. So I can put it here, I can stick my little battery here, attach the ammeter to the battery. I guess I could technically break this connection, stick an ammeter in here to get the current between the two, and then run a wire here, run a wire here. Go ahead, stick an ammeter here, and then run the last wire to close the connection. Now I've got the current for each of these. If I want to measure the voltage across, I just move the two leads basically so that they are making contact with the essentially the wire between the two ends of the resistor. I should do the same with the other resistor. Okay, this is the series connection. Was to also do a parallel connection, so let me set that up real quick. This is a parallel connection of the same two resistors. Again, you want to measure voltage drop across and current through. You can have these ammeters set up like this to get all the currents if you'd like. And then the last part is if we replace the two resistors in each of these cases by a single resistance which draws the same current from the batteries, what resistance value would we use in each of these two cases? So you can do the Kirchhoff's rules, but as a lab, what you're meant to be doing is essentially, let's move these aside for a second. Essentially what you're doing is you're setting up the same battery over here. You're setting it up at the same voltage, which you're actually supposed to be using 12 volts. I'm using 9 volts just so that I'm not giving you all the answers. But essentially, like, you can move this slider here to get your 12 volts. So That's just kind of an aside that I probably should mention. What you're supposed to be doing is taking your resistor, you get your ammeter, you really want the same current, let's say here, and you want the same voltage drop as what you were getting in each of these two circuits. So let's put the probe across like this. It should be 9 volts. This current should match basically this current right here. So in my circuit's case, that means 0.3 amps. In your circuit's case, it's going to be a different number. And so what you're supposed to do is drag the slider until the current here matches the current here. And once that happens, then you basically have the correct equivalent resistance. Okay? So that's what that part is asking you to do. Now, basically, the next part is essentially do the same thing again, but this time, instead of both of these being at 60, make one of these be at 120. So I've now changed one to 120. This would be my parallel circuit. I also set up my series circuit. And once again, I would come down here and adjust this to get the same current as I have here, and then again with a series get the same current as I have here at this point of the battery. Once I have the same current here and here, then what I have for the same voltage is what we'd call the equivalent resistance. So for example, with this one right here, let's go back. Let's actually make them both, say, 40 ohms, just to make it different than what you guys have. But see, the current in my case is 0.45 amps. I'd basically come over here and I would adjust this until I have, again, 0.45 amps, which is right about here. So that's 20 ohms. So I'd say that the equivalent resistance to the combination that I have here is 20 ohms, because I've got 9 volts. And if I come over here and measure voltage drops across these, it'll also be 9 volts. Okay, so equivalent resistance is 0.45 amps. So that takes care of steps 1 and 2. Now that we've done these first two, now we're on to something a little more complicated. We're going to use 3 resistors at 10, 20, and 30 ohms. We're basically placing the larger two in parallel with each other, and then this combination in series with the smaller resistor. All right, so we come back over to our page here, and that will look something like this. Where once again I am using different values than the ones that I necessarily want you to use, just so that you can't copy the values off this video and call it good. This one is the smallest one. It is 10 ohms. These two are not the 20 and 30 ohms that the instructions call for. That's by intent, but they are both larger than this one's resistance. They are in parallel with each other. The combination's in series with this. I'm measuring current at essentially out of each resistor, and also current going into this one resistor. Once again, you're told to essentially figure out if the ratio of currents is the ratio of their resistances, which is 2/3. In mine, obviously, that's not going to be the case because I have a ratio of 60 to 40. So that is actually 2/3 in my case as well. And my ratio is 0.11 over 0.16. It's not the same ratio because this one right here is the 3 in that 2/3. This one right here is the 2 in that 2/3, but this one has the higher current. So you'd best figure out like what the pattern is between these. Okay, moving on from there. what's the equivalent resistance to that combination. So once again, we would pop over here, adjust this one until I have the same current here as what I have here. So in this case, I'm looking for 0.26 amps. You'll be looking for whatever value you happen to have here. Next part of the lab is to essentially take these three and combine them in whatever way we want, but so that you always have at least two in series and at least two in parallel. So these are basically the diagrams that go with that. You're just swapping around the values of R1, R2, and R3 of 10, 20, and 30 ohms. And what you're looking for is which one gives you the largest equivalent resistance and the smallest equivalent resistance. By the way, if you push these buttons down here, you switch from the circuit pictures to their symbols. So you could, in fact, literally on the screen make it look like either one of these if you so desired. Last but not least, you're supposed to build this combination. This combination, in some sense, has a bunch of resistors that are, you could put them all in a line if you wanted to, and then you have a wire out and you have a wire out. And you're supposed to figure out what the equivalent resistance of the entire thing is. So you should have 5 resistors, and essentially what these junctions look like is this. So here we have built this system. You still have to, of course, wire the battery into it, and you've got to wire your second circuit that has one resistor and one battery. Again, you're using your ammeter and your voltmeter to measure what the equivalent resistance is. You are essentially measuring across this entire thing, and you're essentially measuring the current through the entire thing. And so you could math it, but again, do the experiment. It may actually, in this case, be easier to just do the experiment than to try to do the calculation for all of you. Okay, and that's the last part of the experiment. So now it's kind of like, what are you turning in? And the answer is, you might as well collect as much of this data as you have into one table as best you can. Or you could alternatively make a table for each procedure with a series and a parallel part, or you could make a table that is like parallel connections only this, series connections only that kind of thing. Obviously, that gets hard because of these circuits here and here not really being the same type as these circuits here and here. So maybe that is another way to arrange a couple tables. You have to have a screenshot of the combination producing the least and greatest equivalent resistance when you're doing this stuff. And then smallest and greatest possible resistance given 10, 20, and 30 ohms, and putting them in either this combination or this combination. And then last but not least, for number 4, you have to take a screenshot of your circuit setup to look like this, and answering this question. So, take a screenshot, trim it to just show the relevant parts, and that's that. And that's the lab. There's no really fancy calculations that you're doing in this lab because you're supposed to be actually building the circuit to find your answers, not doing the math. You can also do the math if you'd like, if you prefer to do that versus guess and check, but ultimately you have to build the circuit. Okay, and that's it. That's all for today's lab. So hopefully you have some fun building these circuits, and good luck.